A customer may place many orders. A teacher may teach many students. But how do we represent these relationships in database design? It all starts with understanding one-to-many relationships. In this video, we'll introduce you to this concept and explores how to identify and represent one-to-many relationships in database design. Before we jump to the one-to-many relationships, I need to refresh your memory on cardinality first. The understanding of cardinality is important to understand one-to-many relationships. But if you are well versed in this concept, you can skip this chapter and jump to the one-to-many relationships. Cardinality describes the number of instances of one entity that can be associated with a single instance of another entity via the relationship. There are two key points on cardinality. First, a relationship between two entities can be broken down to two different directional relationships when you look at it from the lens of cardinality. For example, think about the relationship between user and account in a database supporting a banking system. This relationship between the two entities are summarized in the two sentences on the screen. A user has 0, 1, or more accounts. An account is associated with one and only one user. The two sentences represent the two different directional relationships. Sentence 1 is about the relationship from user to account, while sentence 2 is about the relationship from account to user. Every relationship can be broken down into two different directional relationships like this. That's the first point. Second, a directional relationship is represented by two symbols of max and min cardinalities. The three individual symbols represent three quantities, including 0, 1, and many. The circle represents 0, the bar represents 1, and the symbol that looks like a crossfoot represents many. Each directional relationship is represented by two symbols as a pair. For example, the first sentence you saw earlier is on the directional relationship from user to account. The two symbols representing cardinalities need to be placed near the account entity. A user can be associated with 0 accounts, so the min cardinality is 0. A user can be associated with as many accounts as possible, so the cardinality is many. The second sentence is on the directional relationship from account to user, and its cardinalities are placed near user entity. Both of the min and max cardinalities are 1. In the end, you are supposed to merge the two directional relationships as one relationship between user and account entities. After they merge, the positions of the two min and max cardinalities would be exactly the same as if you draw them individually. From the lens of cardinality, we can put all the relationships into three baskets, including one-to-one relationships, one-to-many relationships, and many-to-many relationships. We will look closely at one-to-many relationships in this video. In a one-to-many relationship, one directional relationship has the max cardinality of 1, and the other has the max cardinality as many. The 1 and many here primarily refer to the max cardinalities of the two directional relationships. If both min cardinalities are 1s in a given one-to-many relationship, it will create problems for data entry when they are implemented as tables. As you can see from this example on the screen, when it comes to data entry, the two min cardinalities as 1s essentially mean that when you try to add a row of data into table A, it has to be associated with an existing row in table B. And when you try to add a row into table B, it has to be associated with an existing row in table A. The association translates to placing the foreign key in both tables, which will cause SQL to complain. Beyond that, you will also have a lot of null values in the two foreign key columns, as the minimum association requirement can't be met in real world. To avoid such issues, it's typical to relax the main cardinality of the many side from 1 to 0. The one-to-many relationships are the most common relationships that are modeled in database design. Let's look at a few examples. Imagine that you're working towards designing a database for an online store named the Sci-Fi Collective, and have identified two entities, user and review. The extracted relationships between the two entities can be summarized as following. A user can write 0 to many reviews. A review can be written by one and only one user. Let's go from here and develop the two directional relationships one after another. A user can write 0 to many reviews. Based on this, we can develop the directional relationship from user to review. The main cardinality is 0 and the max cardinality is many, so you can add the two symbols accordingly. Since the direction goes from user to review, both symbols should be placed closer to review. In contrast, a review is only associated with a single user, which means that both the min and max cardinalities are 1. This relationship goes from review to user, so you will place the two bars as a pair closer to user. After that, you will merge the two directional relationships into one. This step is relatively easy to do, because all the cardinality symbols stay where they are in the directional relationship representation. They just share the same line between user and user address entity. There is still one more step, which is to explicitly list all the attributes. As you do that, you need to place a foreign key in one of the two entities. And in one-to-many relationships, the foreign key is always placed in the entity that's close to the max cardinality of many. In this example, that's the review entity. So the full representation of this relationship is like what you see here on the screen. The foreign key is in the many side. Email as a foreign key is placed in the review entity. Let's look at another example. For the same database, you have identified and developed two entities, user and purchase. Their relationship is summarized as what you see here on the screen. A user can make multiple purchases. A purchase can be made by only one user. A user may make 0 to many purchases. Based on this, we can develop the directional relationship from user to purchase. The mean cardinality is 0 and the max cardinality is many, so you can add the two symbols accordingly. Since the direction goes from user to purchase, both symbols should be placed closer to purchase. In contrast, a purchase is only associated with a single user, which means that both the min and max cardinalities are 1. This relationship goes from purchase to user, so you will place two bars as a pair closer to user. After that, you will merge the two directional relationships into one, like this. Translating this relationship to their full representation, you need to make all the attributes of both entities explicit. Beyond that, you also need to add a foreign key to the many side, which is the purchase entity, like this. Let's see second example. Let's look at another from the same database. The entities payment method and purchase. Their relationships are as follows. A payment method can be associated with many purchases. A purchase is associated with one payment method. It's simply another classical one-to-many relationship. If you follow the same steps to establish the two individual directional relationships and merge them as one, you will have something like this. The next step is to make their attributes explicit and add the foreign key to the many-side entity. However, before you start, you should know that we have already established two relationships among the three entities. I mean, between user, purchase, and a payment method. We have already added two foreign keys into the payment method and purchase entities. This is based on the work we did in the first two examples. Once you establish the one-to-many relationship between payment method and the purchase entities, purchase will have two foreign keys added to it, email and payment ID. That's not the issue, but you may notice that the three entities form like a circular relationship, right? That's the issue. And it can definitely lead to some problems. This is something that we will address in the future when we cover normalization. Regardless of that, you did a great job in picking up everything about one-to-many relationships so far. In this video, we learned everything about the one-to-many relationships in database design. If you find this video helpful, give it a thumb up, subscribe, and leave your questions in the comments. I would love to hear what's working for you and what needs to change. This video is based on the book Grokking Relational Database Design, which dives deeper into database design using real-world examples to explain the concepts. You can find the link to the book in the first comment.